Well, hello there. I'm Dr. Matt Bracewell with Liberty University Online Academy, and I'm going to talk to you for a few minutes about Lewis dots. Okay, this is part of lesson 10.33M, and before we get started, a good thing to do anytime that you do chemistry, anything physical science related, it's always good to have a copy of the periodic table close by. So if you'll get a periodic table, something to write with, paper, pencil, or if you have access to a whiteboard like I have, that'll be good too. Okay, so what is a Lewis dot? Okay, what do they mean? A Lewis dot is a way to represent the number of valence electrons that an atom has. Okay, so I've got lithium drawn here. Lithium on the periodic table is number 3, which means it has 3 protons in its nucleus, and it also has 3 electrons. Okay, electrons, of course, are the subatomic particles that orbit the nucleus. They're responsible for bonding. So since lithium has 3 protons and then 3 electrons, if I use my pattern here of the Bohr model diagrams, I know that lithium is going to have 3 total. I can have 2 valence electrons on the first ring, and I can have whatever's left over on each additional ring. Since it only has 2 rings, if you go back to previous lessons, lithium has 2 rings because it's on period number 2 of the table. Okay, so in this ring I have my 1 valence electron. So if I were to draw this in Lewis dot form, this is what it would look like. So if I want to draw the Lewis dots for lithium, the way that I would go about it is I have to first off realize that the most dots I can have around any element at any time is going to be 8. 8 means that an element, when it has those 8 valence electrons, that means that it is stable, it has a full outer shell, which means that it will not bond with any other element, or it's not very likely to. So elements like neon, argon, krypton, the noble gases, they don't bond with anything because they have those 8 valence electrons. Okay? So lithium, as we just established, only has 1 valence electron. It's in family or column number 1. And everything in the alkali metal family only has 1 valence. So for me to draw the 1 dot, a lot of people say, where do you put that dot? Do you just, can you just pick a side? How many can you put on each side? Well, this is the way that I learned over 25 years ago, and it's always helped me to keep things balanced here. Okay? So lithium has 1. What I'm going to do is pretend like there's 8 available spots around the lithium symbol. Okay? So I can choose any side that I want to, and I always choose the bottom right. I guess I can use this to white. I always choose the bottom right because it's easier for me to go clockwise just to keep me kind of organized in my mind. It doesn't matter. You could actually choose here, here. It does not matter. But whichever place that you choose, you either continue clockwise or you continue counterclockwise, and you never put more than 1 dot on each side until you've gone all the way around. Okay? So with lithium, it only has its 1 here. I would not put any more dots on any other element until I've put at least 1 dot on each side. Okay? So with lithium, it has its 1 valence electron, its 1 dot. That's what lithium would look like. Same thing for sodium, same thing for potassium, rubidium, cesium, francium. Anything in family 1, they're all going to have only 1 dot. Let's look at another example of an element from the other side of the periodic table. Let's take carbon. Okay? Carbon has a symbol of C. It's in family number 14. It's in row or period number 2. So as you're looking at your periodic table, everything in family 14 has 4 valence electrons. Now the cool thing about the periodic table is if you look at it, everything in family 1 will have 1 valence. Everything in family 2 has 2. You skip over the transition metals. Everything in family 13, like boron and aluminum, they're going to have 3 each. Carbon, silicon, germanium, they're all going to have 4 each. Family 15, 16, 17, and 18 have 5, 6, 7, and 8 respectively, until, of course, like we mentioned, you get to the noble gases. But carbon has 4, okay? So I'm going to use what we just talked about, and I've got these 8 available X's, okay? Now, for me to do this correctly, or at least the way that I've learned how to do it, I'm going to take 4 of these dots, and notice I skipped a space each time. Okay, 1, 2, 3, 4. and then I go back in. I can erase my X's. You don't have to use these X's, but getting started, I have found that this helps a lot of students, even at the honors chemistry level, to keep things organized. Okay, so as you can see, it forms a little diamond there. Carbon, and carbon actually does form diamond because, of course, it's in coal, and then, of course, coal becomes eventually diamond. So it's kind of ironic that that happens, but nonetheless, this is how you would draw the Lewis dots for carbon. Okay, now, what are these dots used for? If I were to take, just say, methane gas, which has a chemical formula of CH4, these lone electrons mean, that's what these dots represent, valence electrons. These lone dots represent electrons that need another electron to form what's referred to as a chemical bond. So when you see these X's, these empty spaces that we just had here, those mean that they have room for another electron. Well, if we look and see CH4, which is in methane, there are 4 atoms of hydrogen that can bond with this 1 atom of carbon. So how many atoms of hydrogen are going to surround this evenly? If I look at it, it has 4 sides. I can put one of my atoms there, one of my atoms here, one of my atoms here, and one of my atoms here. And if you notice, it it creates this little pinwheel shape, which you'll learn about in chemistry, that's called a tetrahedral shape. You don't need to know that now. I'm just trying to sound smart. But those dots together are going to form these lines, these dashes, which are chemical bonds. So as you see, carbon and hydrogen now have this bond, this chemical bond that holds them together and has created a new substance. And this was all because we knew how to use the Lewis dots to put these together. You can do the same thing with water, carbon dioxide, any type of chemical reaction, any type of chemical compound, you can use Lewis dots to represent those. So I hope this has helped you out. If you have any other questions or you need additional help, please feel free to contact me at jmbracewell@liberty.edu. I'll look forward to hearing from you. Hang in there, do the best you can, learn all you can, and God bless.